everyone. Hello, everyone, and welcome to the Current, the North Central Region Water Network's Speed Networking Webinar Series. The North Central Region Water Network is an extension-led collaboration among land-grant universities in 12 Midwestern states, and we build capacity for effective decision-making on water-related issues. I'm Rebecca Power, and I'm Director of the North Central Region Water Network, and I will be your moderator for this webinar. The purpose of the Current is to increase access to university extension programming and research, and we hope on various topics that you'll find useful in your own work. The format of these webinars is 3 10-minute presentations with questions and discussion at the end. All webinars are archived on our webpage, and that URL is northcentralwater.org, and we'll share that with you at the end as well. Our topic today is harmful algal blooms, and I want to thank Lois Wolfson, who I think is online here. She is our network leadership team member at Michigan State University, and she helped to organize today's webinar. And thanks in advance to Chris Winslow from Ohio Sea Grant, Sonia Joshi at the NOAA Center for Excellence for Great Lakes and Human Health, and Greg LaBarge from The Ohio State University. They are our 3 speakers for today, and you'll learn more about them as we go along. This webinar is the 10th in our series, and just a commercial for next month. That one will be held August 19th, same time, 2 p.m. Central, 3 p.m. Eastern. And the topic of that webinar will be various aspects of citizen water quality monitoring, with a particular focus on nutrient monitoring and citizen science. We have some tips here for a smooth experience. You should see on your screen now. Most of you will probably not be using a microphone, but we have a small enough group here that we want to welcome you to run the audio setup wizard, as it says here on the screen. If you do that, you'll be ready to ask questions orally of our speakers. You can also submit your questions in the chat box, which is in the lower left-hand portion of your screen, and we will be collecting those and helping to facilitate questions for each of our speakers at the end. You can also ask questions if you're having trouble in the chat box, and Janice Kepka, who is helping us out with moderation here, will make sure we get those questions answered as well. That said, here's our list of presenters, and we're going to get right into it and start off with Chris Winslow. Chris received his bachelor's degree from Ohio University and his master's and PhD from Bowling Green State University. For the past 9 years, Chris has been at OSU's Stone Lab teaching aquatic ecology and mentoring college students in the lab's research experience for undergraduate scholarship program. Prior to joining Ohio Sea Grant and Stone Lab, Chris was an instructor at Bowling Green State University and an assistant professor at Kutztown University of Pennsylvania. His research focuses on behavioral, population, and community ecology of fishes with an emphasis on the impact of invasive species. And recently, his research and time have been focused more on Lake Erie nutrient loading and harmful algal bloom issues, which is why he's here with us today. And I will say, one of the reasons that we do these webinars is so you get to know the people that are doing work on various different water-related issues in our region, and that's why we take the time to read those bios as well as having you have a chance to read them on screen yourselves. So, Chris, welcome.
Thank you very much for that introduction. So 10 minutes, so this is going to be kind of a quick and basic introduction to this. I don't want to go over my time limit, but I really look forward to the opportunity to answer your direct questions. I'll go right into the next slide. Basically what I want to talk about is, what are these organisms? Okay, what are they? Well, most people call these harmful algal blooms algal species, but technically they're a bacteria. So really I want to just set the stage and make sure everybody's on the same page with algae. Algae are tiny plant-like organisms that live in the water. We say plant-like because they don't have a vascular system and other characteristics that plants do. There are hundreds of species in Lake Erie, and most of them are beneficial. So when people hear about this harmful algal bloom in Lake Erie, we need to make sure that the general public recognizes that not all of these algal species are harmful, and actually most of them are not. As far as in Lake Erie, we see three major groups kind of blink on and blink off as we go through our season. So early in the spring, we start off with diatoms, very lipid-rich organisms, essential for spawning fish and larval fish. As the temperature of the water and the day length changes and even nutrient concentrations change, these diatoms will give ways to larger populations of green algae. And then again, as we go through the season, the greens dominate usually in late spring, early summer, and then we start to see the greens die off in number, and we then get introduced to our blue-green algae, which have a preference for warm water. Of this group of blue-green algae, which again they've been called historically, technically they are cyanobacteria, there are three major groups that we bump into in Lake Erie, and they're Anabina, Anaphamozomenon, and Microcystics, affectionately referred to as Annie, Fanny, and Mike. The one on the right, Microcystis, is the one that's causing us most of the problems as far as toxins are concerned in the lake. So that's what they are. The next question I was asked to kind of touch on is where do they come from? And the simple answer for this is actually the cells themselves come from the sediments that are found in the sediments of both rivers and the lake bottom itself. So what I think is actually more important to highlight is the fact of what takes these organisms that naturally occur in the sediment and makes them achieve bloom conditions. So what you're seeing in this graph on the y-axis is percent land cover. The bars represent the 5 Great Lakes, and I've got a green box around Lake Erie. What I want to highlight then, if you look at the bottom, we are first of all the Great Lakes in residential areas. So we have the most people in our watershed. 11 million people count on Lake Erie for drinking water annually. We're also first in croplands. We have a lot of agriculture in the area, which of course means that there's a lot of nutrients in the form of fertilizers. We are second of all the Great Lakes, only behind Lake Ontario in pasture land. So that means there are a lot of animals in the watershed, and therefore some manure that has to be addressed or disposed of. We have the least amount of forest in the Lake Erie watershed, and although we don't have the least amount of wetlands, you can see Lake Superior and Lake Ontario have fewer wetlands, but we only have about 10% of historic wetlands. So with this all together in one big picture, because of this land use I just showed you, Lake Erie gets more sediment and nutrients, and those nutrients are in the form of commercial fertilizers, manure, and sewage than all the other Great Lakes combined. I have this in parentheses 50-2 rule. This illustrates this by showing that Lake Superior has about 50% of all Great Lakes water, but only about 2% of the fish biomass. Lake Erie, on the other hand, has about 2% of all the Great Lakes water and 50% of the fish biomass. So it is a very nutrient-rich system. What I want to draw your attention to is the figure in the bottom left, which shows discharge of water coming out of the Maumee River. And then I want to compare that to the DRP, which is the figure to the right. This shows dissolved reactive phosphorus. What we're getting at here is that whenever you see a storm event in the Maumee, you see a corresponding load of phosphorus. So everywhere I point on this green line for the 20,000 or 2011 data, every time you see a huge discharge of water, you see a corresponding increase in phosphorus loading. And so what I really want to drive home again is like, the question is, where do these blooms or these harmful algal blooms come from? Well, it's primarily from these large phosphorus loads. And what's alarming for us is that because of global climate change, we're seeing that this nutrient loading is being exacerbated by storms. The number of storm runoff events per year is up 67% since 1960. The number of spring events is up 40%. And the annual discharge, so the size of these rains events, is up 53%. This shouldn't come as a surprise to anybody. For Ohio specifically, we're seeing one of the wettest Junes on record. And our harmful algal bloom forecast that was released that Sonia will refer to is a pretty high bloom this year is in the forecast because of this large input of spring discharge, which then corresponds to a high load of phosphorus. What I want to show you here is that what we really need to focus on when we talk about phosphorus is not total phosphorus, because we're only seeing about a 13% increase in total phosphorus since 1990 to roughly present day. And of this total phosphorus, usually only about 25 to 50% of this is readily available. The research that's going on right now is really focusing on this DRP, which is our dissolved reactive phosphorus. This, for the same time period, 1990 to roughly present, we've seen a 144% increase in dissolved reactive phosphorus. So this is the phosphorus that's, as the name suggests, dissolved in the water and being carried in primarily in these large storm events. We can make these predictions about how bad the harmful algal bloom will be primarily based on, with a few caveats, the discharge coming out of the Maumee River into Lake Erie. And most of this is coming in the form of DRP. What I want to show you now is the loading of phosphorus, and this is total load of phosphorus across all the large tributaries throughout the Great Lakes. And what you'll see, if I can draw your attention to the middle bottom with the finger pointing, about 3,812 metric tons annually are coming through the Maumee River. This is in comparison to things like the Detroit River, which has 2,000 metric tons annually. So you can see of all the Great Lakes tributaries, these two areas are where the largest inputs are. I often note too that Sandusky is here at just over 1,100 metric tons annually. But the reason why I bring this up is because this Maumee River contribution of total phosphorus is where we need to draw a lot of our attention. People, by looking at this graph, would think, well, why isn't the Detroit on the radar as something to address too? Because we always want to focus when we talk about these things that it's not necessarily the load of phosphorus coming in, but it's the concentration. And so what you're seeing here is that even though 2,000 metric tons of phosphorus are coming into Lake Erie from the Detroit River, that's also where 95% of the lake's water is coming from. Where this 3,800 metric tons of phosphorus coming from Maumee, that's only where about 3 to 4% of the lake's water is coming. So these blooms that we can predict in the summer are being driven primarily by this concentration of phosphorus coming from the Maumee River. So trying to get at that idea of where do these things come from. This is that same kind of information. So as you can see, the figure on the left is an average of inputs of total phosphorus from 2011 through 2013. And you can see, roughly 41% has come from the Detroit, 47% from the Maumee, and 12% from all other tribs. But if you look at the average flows, you'll see that the Detroit River, again, is contributing about 95% of the water, and the Maumee about 4%. So it's really that idea that it's not just where the phosphorus is coming from, but is it in a concentration high enough to drive blooms? As far as to round out this talk, I really want to talk about some research initiatives that are happening in Lake Erie specifically related to these blooms. We recently received $2 million. When I say we, Ohio Sea Grant is managing these funds, but the research is being done by 8 different universities and 18 different PIs. But that money is going into one of these 5 focus areas, or all of these 5 focus areas. The first one is really looking at how do we detect, map, and put together a warning network for these harmful algal blooms. So there's 2 projects that reside within that focus area. These algal blooms issues aren't likely going away quickly, but it's going to recall for a 40% reduction in phosphorus loading across the Lake Erie watershed. But what we do need to be able to do is make sure that while we're lowering these phosphorus levels over the next 5 to 10 years, that we have safe drinking water. So some of the money coming from the Ohio Department of Higher Education is going to arm water treatment plant operators with tools, technologies, and training to remove the toxins. Also, some of that $2 million coming from the Ohio Department of Higher Education is going to address land practices. So what can we do at the edge of farm fields, and what BMPs can be implemented to help lower that amount of phosphorus entering the system? The 4th focus area is human health and toxicity. So this is looking at what do these toxins actually do to humans if they are in the drinking water. So one thing is to look at fish tissue. Current data suggests that the fish are healthy to eat in Lake Erie, that these toxins aren't accumulating in the fish tissue, but we're going to continue those studies. Looking at the impact of the liver on individuals that consume this water. Also things like, that's not listed here as an example, but if you water your backyard garden with water with microcystin in it, are those fruits or vegetables safe to eat? And the last major focus area that we look at is economics and policy. So what can we put in place to help make these changes that have to happen on the landscape, this 40% reduction, possible or feasible? I have 2 other slides that I thought if I had time I would get to, but given the clock that I'm on, I'm actually going to skip over some of the agricultural recommendations that we typically have and some of the other levels that can be turned outside of agriculture. I thought this would be the case that I wouldn't be able to get to these slides, but I'm happy to discuss some of the things that farmers and that property owners can do to help lower this phosphorus input.
Excellent, Chris. Thank you. And again, just a reminder to folks, if you have questions for Chris, stick those in the chat box in the lower left, and we will harvest those for after our next two speakers. And our next speaker, Sonia Joshi, is an Ag Communications and Outreach Specialist for the Cooperative Institute for Limnology and Ecosystems Research. Sonia's primary role is to work with multiple stakeholder groups such as drinking water operators, beach managers, and county environmental health officers to identify and assess stakeholder needs related to harmful algal blooms, to help them and also to guide various different research efforts. She also works to translate research tools and technology for stakeholders using social science methodologies and participatory action research to assist local managers in decision making. Prior to her current position, Sonia worked for 9 years as outreach specialist for Michigan Sea Grant Extension and coordinated stakeholder involvement and outreach with the GLERO, that is Great Lakes Environmental Research Laboratory, based in the NOAA Center for Excellence for Great Lakes and Human Health. Sonia also worked for the Ingham County Health Department and has experience in the nonprofit sector. She has a master's degree in the human dimensions of fisheries and wildlife from Michigan State University. Thank you for joining us, Sonia, and go right ahead.
Great. Well, thank you so much, and thank you for this opportunity to present to you all today. So what I'm going to be doing is talking specifically about the forecasting products that the NOAA has available for local managers and for the general public to utilize. And I certainly want to just mention that doing this type of work, this is something that we've been involved with for 10 years now, actually even greater than that, but specifically forecasting harmful algal blooms for the past 10 years. And it's certainly a multidisciplinary team with different entities within the umbrella of the federal agency of NOAA. So these are just some very important people that have contributed to the slides that I'm going to be presenting on today. Sorry, how do I go to the next slide?
There are arrows in the upper right just above your slides that you can use to switch the slides.
Okay, thank you. Sorry about that. So one thing that perhaps many of you are well aware of, we issue a bi-weekly NOAA Lake Erie harmful algal blooms forecast bulletin, and this summer is actually our 7th year doing this, and this is just a schematic of what it looks like. And what it provides is, utilizing satellite imagery, we have an observation of what the bloom is looking like, and then utilizing some specific models, we provide a forecast of where the bloom will be moving 4 days later. And then we also have a write-up, just kind of an overview of what is happening with the bloom, what the forecast is actually predicting to be occurring in the next few days. And then also we provide the microsystem, so the toxin concentrations of GLERO's weekly monitoring as well in the weekly bulletin. And actually last year, because of what happened in Toledo, we moved from just doing it weekly to bi-weekly. Certainly we're just trying to make sure we're as proactive as possible to community and local manager needs. Also this year, this was new, and this was also at the request of many people, we provided an early season projection, so just kind of to build up to the now almost annual for the past 4 years, annual season kind of projection of what the harmful algal bloom outlook would be for Lake Erie. We provided an early season projection, and so perhaps many of you tuned in last week to the forecast that was held in Chris's shop at Stone Lab. But what it utilizes is a number of different information from various collaborators, in particular Heidelberg University provided a lot of the nutrient load data that fed into the models, and there was different researchers that contributed to help with forecasting what the blooms forecast prediction would be for this year. And the projection, if you missed it, is that this bloom is potentially going to be almost as bad as 2011. There's still a lot of factors that, we can't say definitively, but it's certainly going to be worse than last year, but and possibly worse than 2013, but there certainly is still kind of an error bar of uncertainty. So it could be as bad as 2011, it potentially could be worse, or not as bad as 2011. But since 2011 was on record the worst that we've seen, we just kind of use that as our benchmark. And so if you need to access the webinar, if you missed it, just let me know and I can provide that web link, or certainly Chris can as well. But also we have a lot of information on our forecast available at the website that's listed here. And kind of in the background, what we've been doing, and we launched this quasi officially last year, is we've also been working to improve the biweekly Lake Erie Harmful Algal Bloom Forecast Bulletin that we have available to provide something that's more real time. So this is something that we're dubbing the HABS Tracker, and it's people, the NOAA facility in Ann Arbor, Michigan has been really focusing on this. And so I'm just listing again because there's a number of people that are heavily involved in developing a lot of this. So we have a huge team that are involved in the monitoring aspect as well as remote sensing, and then the modeling as well as communications. So this kind of fits into a whole suite of what specifically the Great Lakes Environmental Research Lab of NOAA is working on just to study harmful algal blooms. So we are focusing on prediction because NOAA's expertise as an agency is in prediction and forecasting events, but we certainly do quite a bit on understanding the environmental triggers of blooms, utilizing genetics techniques. We've been doing intensive monitoring in western Lake Erie for a decade now, and so that allows us to really have a handle on the community changes and just what's been happening out in the lake for the past several years. And then we're also doing other experiments to understand, for example, things like the influence that zebra mussels have on microcystin proliferation, and just kind of the dynamics of just other organisms and how they might be contributing to the growth and proliferation of these blooms. So with the HABS Tracker, what this is, and it's just really kind of what we see as being kind of the 2.0, the updated version to provide information to community members. But so what it does is it provides, instead of a weekly forecast or a bi-weekly forecast, the HABS Tracker is available daily. It still utilizes weekly monitoring from the Great Lakes Environmental Research Lab. There's some slight improvements to the satellite algorithm, so just it provides for kind of some atmospheric correction. And then rather than using 2D surface particles as kind of the forecast to predict where the bloom would be moving, we've actually been able to integrate and translate the particles into a three-dimensional aspect. So that actually mimics more so what microcystis looks like, because microcystis in itself are colonial, so they're just individual cells, and they certainly do grow within the water column, not just on the surface. So this allows us to provide just a little bit more accurate information. And then even with the 5-day forecast, that also incorporates three-dimensional currents from some improvements to the Lake Erie operational forecast system. So it's just some improvements that we're really excited to be providing to people. And again, sampling and just looking at what's actually happening out in the lake is extremely important. We go out weekly from June to October, and that allows really for the ground truthing for the forecast. And we're not just monitoring for microcystis or microcystin, but a variety of parameters that really contribute to the growth, or just allow us to have more understanding of the dynamics of just growth. And I just want to point out Western Lake Erie 12, that point is actually where the Toledo water intake is, and that's someplace that we've been monitoring since 2005, so we were certainly well aware of what was happening. But since we only monitor on Monday, the situation last summer occurred towards the weekend on a Friday, so we unfortunately were not out there then, but our forecasts allowed us to give a heads up to the Toledo water intake managers. We're also doing some continuous monitoring because we can't be out physically every single day, 24 hours a day. We have some moored instruments that allow us to provide just some more real-time information to help calibrate and validate our models. And why that's really important is if we were just to rely on just our weekly monitoring, those are the red squares here, just for dissolved phosphorus, we would certainly miss a lot of peaks and those are the blue diamonds that you see here that are just the actual hourly measurements that are coming from our moored instruments. So it just gives us a clearer picture of what is actually happening in the water. With the algorithm approach, the satellite data that we're utilizing is really something that just allows us, as I mentioned, to be able to do a more accurate matchup from what the bloom looks like. So I don't want to go too much into the algorithm development, but just to compare it to the extent, it actually, this is just a snapshot from last September, it does a good job of just recreating what the bloom is looking like. And then this gets fed into our hydrodynamic forecast. So just hydrodynamics is water movement. It incorporates winds, the currents, just the water movement within the water column. And we have hourly currents, so that allows us to just get a perspective of where the HABs might be moving within the water column as well. And then so how the HABs tracker works is that we take our algorithm, we translate it into the particle trajectory model, which allows us to provide a 5-day forecast. So we run it through our Great Lakes Coastal Forecasting System, and then it provides just what would be listed on the bottom of the screen. And this is something that we provide. It's available on our website. Right now it's available real time. It's updated every 15 minutes, and it provides a 5-day forecast out of where the bloom is moving. So compared to what we have available with the biweekly bulletin, which is only issued twice a week, this is something that's available just in real time. So I'm going to skip over this information because I know that I'm running over my time. But if you guys have any questions, here's my email address. And then certainly these are the websites that you can access all of our information. Thank you.
Excellent. Thank you so much, Sonia. And this isn't a question, it's a question, but it's not a content question. You had mentioned you had a link to a webinar that people might be interested in, and if you could just put that right into the chat box if it's easy to do, that would be great, and then people can see it and copy it if they're interested.
Sure.
Thank you. Okay, and on to our final speaker, Greg LaBarge. Greg LaBarge is a graduate of the University of Missouri Columbia with a bachelor's degree and a master's degree in agronomy. He has been with Ohio State University Extension since 1987, serving as an extension educator in Fulton County from '88 till 2011. And since 2012, he has been in a statewide role of field specialist in agronomic systems. His area of focus include integrated pest management of disease and insects, soil fertility and nutrient management, and precision agriculture. He has represented the College of Agriculture, Food and Environmental Sciences and OSU Extension at various nutrient management, water quality related events, committees. He has served on the Ohio Phosphorus Task Force, Phase 2, and has been part of a group establishing the 4R Certified Ag Retailer Program for the Western Lake Erie Basin. So we've gone to a lot of what's happening in the lakes, and as Chris said, Greg is going to help us get into more detail on the agriculture side and how we're working on the landscape to minimize those harmful algal blooms in the lake. So thanks, Greg, for joining us.
You're welcome. Appreciate the opportunity to share a few things with you as far as what's going on with nutrient management education here in the state of Ohio. I guess kind of putting things into perspective, when Chris talked about the extent of agriculture in the basin that we're talking about, it really represents about 4.2 million acres of land base that is agriculturally related, and most of that is in row crop production. So we, while we are a big contributor, really when you start breaking it out by that volume of land, what it ends up being is a really small amount coming from a large number of acres as far as the agricultural contribution. So a few things have happened here in the state that I want to share with you, things that we're doing from an educational perspective, and also our legislative bodies have been active in a couple of different aspects, and we'll get some information to you on how we're approaching some of the issues related to nutrient management. We really focus in the Lake Erie Basin on the phosphorus issue, but we are also a part of the Ohio River and ultimately the Mississippi River watershed, so nitrogen is important as well, and really those are the two nutrients of focus. We do have some legislative action that took place in 2014 and then earlier this year. In 2014, the program fertilizer applicator certification training was established. Recently we had Senate Bill 1, which put some application criteria in effect for the region that we're talking about up in the northwest corner of the state. Then we also have some educational things that we're doing in the field and some new projects gearing up, and I want to share with you one slide on why these field results are so important. Just a little bit on the fertilizer applicator certification training. It is a joint program. If you're familiar with pesticide applicator training, it's modeled after that here in the state, with the Ohio Department of Agriculture being the issuing authority as far as the certification or certificate is concerned. We as Ohio State University Extension provide the educational session which is required, and that is with a pesticide license you need a 2-hour session to qualify for that certification. Without a pesticide license, it's a 3-hour educational program. We had the bill become effective and the program start in August of 2014, and we actually began some training sessions in September due to the issues that were experienced there in Toledo, and wanted to be proactive. You can see that we've had about 6,500 people that have gone through those sessions, and we did, as our ground folks, extension educators over the state, conduct 110 sessions. And once again, this fertilizer applicator certification is a statewide program. This kind of gives you a perspective, and a lot of the certificate holders that we have currently are up in that northwest corner. Probably not real easy to see, but the darker the brown, the more numbers of folks that have their certificate issued, and you can see that it does exist in that corner of the state. This is the training, and I won't go through this line by line, but certainly what we're doing is covering nutrient enrichment effects from phosphorus and nitrogen, talking about management from a yield aspect, yield and economics, as well as looking at some of the water quality impacts. You can see the link there that leads to the materials that we used. The manual that you see there pictured is at that website, and as well as a lot of the presentations that we put together in relationship to that training effort. We have done some after-meeting surveys. This kind of gives you a summary of that. I guess part of what we're doing with this program, and we knew that would be occurring up front, is that we do have people that have never attended our extension program attending these sessions. So we really wanted to make the program useful for not only the folks that have been long-term supporters and people that have taken advantage of extension, but highlight some of the materials that we do have through extension that can be helpful for farm management. I guess just highlighting that first question on the survey, and there's a number that aren't represented here, but one I think that's really significant, and we see this kind of over and over, is that farmers really do understand that farm related phosphorus is a significant problem to water quality here in the state, and a very strong agreement with that in a number of different surveys. So we have an audience that is somewhat engaged, and I think with the other 2 or 3 questions there, you can see that they're gaining something from this training effort. So that kind of summarizes the FACT training. Here what you have is our Senate Bill 1 materials came into effect on July 3rd, so just a couple of days ago. These criteria came into place. An important part of that is a criteria for manure and granular fertilizer application. We're really focused in on just those granular fertilizers with phosphorus and nitrogen in them, but you can see that there's 3 criteria that people have to think about in relationship to application. No frozen snow-covered applications where the top 2 inches of soil are saturated, and then taking into account a weather forecast. It's a 24-hour forecast for manure or a 12-hour forecast for granular fertilizer. And what we're talking about is what the forecast is for, in the case of manure, it's a ½ inch of rainfall. If we're talking about the granular fertilizers, it's a 1-inch rainfall being predicted over those time periods. This is not a statewide piece of legislation. It is actually targeted towards the western Lake Erie Basin and the Sandusky Basin, as you're looking at the map there with those highlighted counties. So this is not a statewide implementation. So that covers a couple of legislative things, FACT training statewide, the Senate Bill 1 with the application criteria targeted towards the western Lake Erie Basin. Both of those are new in either late fall of 2014 or here early spring of 2015. We have a variety of educational programs going on across the state that are in the field, on-farm research type of activities. I'll share a few of those with you here. One of those is we are working towards validating our nutrient recommendations. Dr. Steve Coleman, who's our state soil fertility specialist, is the lead for that with funding from primarily our commodity groups, looking at revision of our recommendations, looking at phosphorus, nitrogen, and potassium in that set of recommendations, and making sure that they're correct from an agronomic standpoint and that we can justify what we recommend. Another education in the field, a lot of on-farm research going on, is really looking at alternative manure application timings, and what we're trying to accomplish with that is really put manure down either shortly after the crop has been planted, or in some cases as a pre-plant, and really use it to replace in almost full part for corn our commercial fertilizer purchase. We're putting on rates prior to corn that with the manure analysis would limit or eliminate the need for any additional nitrogen application. In that, what we've seen is that it will balance out over a 2-year period the phosphorus that we need for that rotation. So in a corn-soybean rotation, we can really eliminate for a 2-year period the nitrogen and phosphorus applications. Glenn Arnold is a field specialist in a similar role to myself, working with manure applications. He's been doing a lot of this work since 2011 and has really progressed from what would be tankers going across the field to now where they're using some of the more volume type of application equipment where we have a drag hose going across the field and placing nutrient with that type of application. A couple of projects then that we want to talk about that we're gearing up for, and these are targeted towards that western Lake Erie Basin, kind of the highlighted in yellow counties seen on the one map earlier. We are looking at nutrient management plan writers. We have secured a grant, then local matching funds that are almost $1 million worth of activity that will go on up in that basin, and you can see the partners listed there. Our commodity groups and Farm Bureau locally have been a strong supporter of this, and will hire 4 people to do nutrient management plans that will help in assisting with the RCPP implementation up in Northwest Ohio, which is a NRCS program. So the plans will meet that criteria for NS cost share and allow us to get some more practices on the field and in targeted areas where we hope they will do the most good. Another project that we're gearing up for is a farmer water quality sampling network, doing some sampling at tile outlets with a diffuse gradient film type of device that will give us in a couple of periods of the year some sampling that will help us understand where some of this phosphorus is coming from. That is one of the projects that, as Chris was talking earlier about the Board of Regents funding that we've got here in the state, it's one that is being implemented from that pot of money, and you can see a link there to some more details on how we're conducting that project. My last really informational slide here with edge of field study results. We are doing some paired studies with capturing both the surface water as well as the tile water from these paired fields. The A and A is one set of fields, BB is a second set of fields, and you can kind of follow across there. And what we start to get is a picture of our DRP loading that's coming from fields via those 2 different sources. You kind of look here and initially you think the tile is a strong contributor, and actually because of the volume of water that we do, we see a lot of total loading coming from tile. But as Chris kind of mentioned earlier, we're starting to look at concentration, and actually the concentration coming out of the tile water is much less than what it is in the surface sampling that we're doing. So we start to get a picture of what tile and surface contributions we're getting, as well as here a kind of a field by field, and we can see that not all fields are contributing equally to the problem, and we start to be able to talk about some fields that maybe we need to target a little more directly with some of our either best management practices or maybe multiple layers of best management practices to reduce the loading from those fields. So appreciate the opportunity to share with you a few things going on here in Ohio as far as our extension programming.
Thank you so much.
And look forward to questions here in a minute.
Go back up to some of our earlier questions here. And Les Everett from University of Minnesota asks, have the wastewater treatment plants, especially the large ones, reached their technological limits yet? Or do they have ways to go in the Lake Erie watershed? And this was either, I think this was during Chris's presentation, but Chris or Sonia, is probably for you.
So this is Chris. So a lot of it is actually just, in some of these cases, it's just the addition of things like activated carbon or potassium permanganate. Excuse me. So those additions don't really require massive renovations of any of these treatment facilities. Now, if you're going to do UV treatment or implementation of membranes and different membrane technology to take the toxicants out, there are some facilities that would need to do some facility improvements to accommodate that. But there are pools of money that have been provided through the Ohio EPA, small grants that these treatment facilities can access to help pay for those upgrades.
And a related question from Lois Wolfson: what methods are being recommended to remove microsystems from drinking water? So I suppose that could either be at a treatment plant or it could be at home.
Yeah, so again, the 3 major ones are UV, activated carbon, and a potassium permanganate. And then the other one, again, that is kind of ramping up right now is different biological membrane filters. So those are the kind of things that can be used as far as city treatment facilities. As far as at home, we're actually currently, the Lake Erie Commission, under their Lake Erie Protection Fund, is funding a researcher with Ohio Sea Grant and Stone Lab, a gentleman named Dr. Justin Chaffin, to actually compare water filters that you might use in, that are tapped into your refrigerator, or even those Brita filters, that style of filter, to look at the ability of those filters to take toxins out. So that information isn't currently known, but there is research that's on a one-year project that basically just started that should be delivering that information soon.
Great, thank you, Chris. And I had a question about, you mentioned some areas of research that are ongoing about our ability to use water that might be higher in microsystem. What do we know about the current human health aspects of watering gardens, for example, with water high in microsystem? And do we know anything about that at this point, or what are the research needs?
No, so that's early in the stages for that. I mean, this money that came from what was formerly referred to as the Board of Regents, they're now referred to as the Ohio Department of Higher Education. That money just mobilized in this spring, so that project is underway right now. As far as the fish tissue work, after filleting a fish from Lake Erie that resided in an area that would be considered a bloom area, there are detectable toxins in the fish tissue, but if you follow the currently established fish consumption advisories that exist for other chemicals that are in Lake Erie, the consumption advisory that's been in place for years and years and years, if you're following those recommendations, the minor toxic levels that are in the fish tissue aren't high enough to have any human health impacts. So we know that the fish are safe to eat. So I have no, for me personally, if I caught a fish within a bloom, I would have no hesitation in consuming that fish. But again, a lot of this is being revisited with new technology to see if we can get a better look at it, and the stuff related to produce isn't out yet.
Great, thank you. And Les Everett asks, how much of a problem is excess livestock density relative to spreadable acres for manure versus the method of application for manure?
Yeah, I guess I'll take that one on, and this is Greg. With our discussion about Lake Erie, it's a little different story than some of our other inland lakes, and we probably shouldn't give the impression, and we know that harmful algal blooms are really an international problem, but here in the state of Ohio we do have some inland lakes that do have issues in relationship to harmful algal blooms, and the primary inland lake that we think about there is Grand Lake St. Mary's, which is a small watershed on the western side of the state. In that particular watershed of Grand Lake St. Mary's, about 70% of the nutrients in that watershed are coming from livestock manure in relationship to needing land application. There's a lot of export in that case out of the watershed to try and get those nutrients spread out, and there is a very strong density of livestock in that area, as you can imagine, with that type of nutrient levels needing to be spread. When we talk about the western Lake Erie Basin, we start to thin out livestock numbers pretty substantially, and really only about 10 to 15% of the nutrients that are in that watershed do come from manure applications and so most and the bulk of what we see as far as nutrient need being met in the western Lake Erie Basin is coming from commercial fertilizer.
Les, did that answer your question, or do you have any follow-up? And if you do, you can feel free to use the talk button and go ahead and ask.
So actually, this is Chris. So Greg's right on with his response, but this reminds me of some other research that's going on right now. There is work happening under what's called the Field to Faucet initiative coming out of OSU's College of Food, Agricultural, and Environmental Sciences, that is actually doing research right now to see if they can actually remove the phosphorus and nitrogen associated with the manure. So that's one step that's going on right now. And the other research project that's related to manure is that there's research coming out of Toledo also that's looking to be able to determine, actually it's out of OSU, that's looking to determine if we can state through chemical analysis what the source of that phosphorus is. So if that phosphorus can be tracked back to commercial fertilizers versus manure versus septic failure versus a combined sewer overflow. So there is research going on right now so that we can actually determine where that phosphorus source specifically is.
Okay, thank you, Chris. and Greg. As a follow-up to something that Greg said about the issue of inland lakes, there are a number of us that will be listening to this webinar that are working more inland and not so much on Great Lakes. For Sonia or Chris or any of you, for those of us that aren't working in the Great Lakes Basin but have issues with harmful algal blooms on inland lakes, are there ways that the NOAA resources, or the resources that are being developed, particularly the forecasting resources, that those are being, is there any look at adapting those for inland lakes, or others of the tools that you talked about, Sonia, that we might be able to use on inland lakes?
Yeah, so I didn't mention it, but specifically in this talk, but we do quite a bit with citizen science as well. What we've had people do, if they're uncertain about if they have a harmful algal bloom, in their inland lake, we've had people send us pictures as well as actually send us samples. If you can collect a water sample for us, you can ship it to us, and then we can analyze it to determine whether it is indeed a blue green algae or not. So certainly if that's something you're interested in, just send me an email. We would like to know in advance if samples are coming in, so that if it's on a weekend, they're not sitting there over the weekend and that type of thing. But then we can give you specific information on how to collect the sample and keep it stored so that it's ready to be shipped to us. We have also, with in particular in some of the more problematic inland lakes in Ohio, for example, Grand Lake, St. Mary's, we do provide satellite imagery and some forecasting, but that's on kind of like very specific scales. It's difficult because NOAA's mission and role is primarily on the Great Lakes rather than inland, but that's why with just volunteer monitoring and kind of more just along the line of just, if people are not sure, certainly just send us a photo or a sample and we can just provide information.
Great, thank you, Sonia.
To add on, this is Chris Winslow again. A lot of the BMPs that are being tested and used to combat the phosphorus loading that's happening in Lake Erie can be transplanted to any watershed. So when we're looking at things like buffer strips or two-stage ditches and things like that, these aren't things that are just unique to the watershed that feeds into Lake Erie. So other inland lakes can still use a lot of the BMPs that are going to be analyzed while trying to address the Lake Erie harmful algal bloom. So I think a lot of this is going to be transferable to other systems.
Greg, anything to add?
Well, yeah, I think just maybe a comment here with agriculture. Probably the low-hanging fruit that you always look for in relationship to what can we tell farmers that would have an impact, whether it's short-term or long-term. And really there's two things that we see through the data from the edge of field that really are telltale things that farmers need to have in mind, and this would cut across any watershed, I believe. And that is, first of all, follow closely the soil test levels that you have out in the field. Don't build them up to excess. As we see higher levels of phosphorus soil tests, we see higher levels of contribution. That one field that you saw in my slide picture is a field that has a level of phosphorus in it that's about 300 to 400 parts per million Malic 3 soil test level. It's a poultry farm that has a long history of poultry manure on it, but the reality is it's been 10 years since it's had any phosphorus application. So that's really kind of a key thing that farmers need to have in mind, and it also relates to economics as well, as in that they don't need to apply fertilizer to those higher soil testing fields once it gets above our agronomic need ranges in all of our recommendations. The second thing is nutrient applied to the surface. Any rainfall event that happens before that stabilizes in the soil, if it's still on the surface, is going to move off-site and move off-site at a higher level than if we get it placed in the soil. So the other thing that we're talking about pretty directly and can add to our recommendations for this year in the training is looking at soil placement. Doesn't necessarily mean or need to be tillage. It just needs to be getting that nutrient placed below the surface where it's exposed to those runoff events if we do have something shortly after application.
Great, thank you, Greg. I had a question. One thing that I've seen quite a bit here in Wisconsin is, farmers sometimes they're not coming to the conclusion that agriculture is contributing to a water quality issue. And it seems like in Ohio you've stepped across that bar. People are the farmers that you're working with say, yep, we know this is an issue. What can we do to help fix it? And how, can you say a little bit about that process in Ohio? Like how did that happen that farmers are coming to that conclusion that there's an issue that they want to contribute to helping with?
I think we've been able to share some data, and it goes back to some of the monitoring data that we're very fortunate to have on the Lake Erie. We're able to really start to quantify from the different segments, particularly point source versus non-point source, what the contributions are, and we're, with some of the edge of field monitoring, start to put together some numbers that represent what agriculture's contribution potentially is to that non-point source. And we're able to show that even with these small levels of a half a pound to 1.5 pounds per acre type of contribution, that it quickly adds up to 60–70% of what the non-point source would be. So people start to get it. I think the other thing that they start to get is seeing that not each field contributes equally with some of the data that we're able to share there. So thinking about some of those higher soil testing fields, thinking about those fields with a recent manure application or a fertilizer application that might be more susceptible to loss. I think they start to get that type of thing. And actually, we probably have a little bit of history that goes back to the first reductions in phosphorus levels in Lake Erie, where a lot of that came from our wastewater treatment plant improvements, but in that same period is where we implemented a lot of our reduced tillage practices and no-till, and there was a lot of success in that and a lot of reductions in relationship to phosphorus coming from non-point sources related to agricultural's contribution. So just trying to put together the picture, and some of that takes a little bit of data coming from those local water bodies and watersheds.
Great, thank you. That's helpful. Any other questions? Okay, seeing none from our group. No, I'm not missing any. I did have one more. And Greg, what percentage of farmers currently have approved nutrient management plans in the Western Lake Erie Basin? You talked about that as being one of your efforts. I was just wondering where you're starting from and maybe where you'd like to get to.
Well, we're starting from a pretty small number. I mean, a lot of the nutrient management planning that would have been done in that watershed would have been tied to a comprehensive nutrient management plan for our livestock operations to gain some equip dollars in implementing storage or other livestock activities. So really, it's going to be we're starting at a very small percentage. It probably numbers in the hundreds versus the number of farmers in that watershed nearing 8,500 farmers in that watershed. So we have a lot of work that potentially can be done in relationship to nutrient planning.
Excellent. Thank you. Okay, any other questions? All right. Well, thank you again to our speakers. Great presentations. And thanks again to Lois for helping us organize, Lois Wolfson. This and thank you to Janice for switching that slide. This session will be available in a week or so online, so you can access the link there, spread the word to other folks that you think might find these presentations useful. Our upcoming sessions, as I said, the next one is August 19th on agricultural irrigation management. September 16th, citizen water quality monitoring with focus on nutrients and water quality. And then we have one in October on farmer leadership and watershed management, and then finally one focusing on stormwater outreach and management. So thank you very much for joining us today, and look forward to your participation in the future.
Thank you.
Have a good day.